we need to have to share the work or the task, the process, to individual computers or individual processes, so that we can actually make the task faster and we can execute it efficiently. So a distributed system, what happens is like messages are actually transferred to a queue server, and from the queue server a consumer is taking the task and processing it. So this talk is basically about an overview of Celery and the installation and use case and minor drawbacks. Major features of Celery. So one thing is like everyone's basically do web applications and stuff like that. When we have a huge process or between a task which take a lot of time, then the request response will take bit delay, right? So we can have to avoid that thing. Another thing is like set a periodic task. What happens is like everyone might be knowing about cron job. So what happens is like a particular task or particular process supposed to run periodically every 5 minutes or every 10 minutes or every day. We can use that thing. So another thing is distributing tasks to multiple computers or multiple processes. Third, it can act as a cron job. So what happens is like a normal scenario, you have a database, you need to take backup of this database every day or every 6 hours. So what you do is basically create a cron tab. You tell the system admin to create a cron tab, and system admin will create a cron tab, and it will run every time, right? So we can replace the cron tab with Celery. Then it's useful for the distributed computer. To install Celery, simple command pip install Celery. So you people, those who are using Python 3, you can use pip, and manual installation pip 3.6 or whatever the version. So to start with Celery, we need to have a 2 to 3 lines code. That's enough. Okay. So the first line say from Celery import Celery. So Celery, after the installation of the Celery, you will get the package library. So you are importing this class from the Celery library. Then you create an app. So the app says that Celery is equal to Celery demo app. So you're creating basically an instance of the class. Normally people call it as app equal to Celery and something, the name. Then a few configurations you're supposed to do. So basic configurations are actually what all the tasks needs to be imported, okay, and what is the broker URL. I will explain you what is broker next to this next slides. And the broker can be AMQP, and it's basically its IP address and stuff like that. And to run Celery, you say Celery -a says that which is the application. It's a file name is demo app, and it has something called Celery. Then we say worker. So it starts the worker. So I will explain you what is worker. So this is a typical use case. What happens is like I have a small Flask applet. Everyone know about Flask? No, people know about API, right? So I have an API, okay? That API basically takes, what it does is actually when it requests, it needs to create a CSV file, and it should say that, okay, the CSV file is sent to the person who is requesting. So in this case, to get that complete data of the client, that 1, 2, 3, what the number is, and process it, it takes basically around 3 to 4 minutes. So do you think that API request will going to give a response back? Normally no, right? It basically give a timeout. Or it will, you will be waiting for 3 to 4 minutes, and at the end you say that okay now, right? How to avoid this problem? So it's, there are few people may wait maybe 3 to 4 minutes, right? Because it's required for them, that's CSV file. So take this example. So someone is giving an account. In this particular account, I have maybe 10 to 15 users or clients or 100 clients. I need to get all the clients. I need to send, create a CSV and process it and send it to them. Now it's more complex, right? This itself will take 3 minutes. 10 user is at 30 minutes, right? So we are trying to solve this issue using Celery. Okay. So from the last this slide, the complex part of, I mean blocking part of the code is generating this process. Rest everything is fine, right? You can create an object of export, it's okay. You can get an account class, that is also fine, it's not going to take much time. And iterating also not going to take time, but this is the problem. So what we are going to do is we take this thing out and put in the Celery. So as I said, so we have basically a Celery app defined, okay, with basic configuration, and I imported that necessary library, and I created app.task. I will tell you what it is. Then what I did is I just created a small function and moved a complete code to that function. So this thing, and the Flask code or the API become like this. Basically, from the task we basically import this function. Okay. Then we say process CSV generation dot delay, then pass the account. So what it does is actually it pushed this task to the queue, what I was just talking about. So what happens is like any to run the Celery, basically we need to have a broker. I will explain broker. So what happens is like it's supposed to, it basically push this complete process functions to a queue. Then the worker will pick the task. So we'll see a kind of another use case in live. Okay, so some sample code I wrote.
Do one thing, Abhilash. Expand upon it.
Is it okay? No.
Control plus.
Oh, good.
Okay. Anybody is saying back? Okay. And if you feel anything uncomfortable, you can shout out. Huh? You don't need to. No problem. We're not communists.
Okay. So okay, so this is example where the real time what we do is like, do you have any idea about sitemap? Anyone? Okay. We need to create a XML file. Okay. To create the XML file, I need to pull all the data from the database. Okay. Then for each entry, I need to basically create a kind of URL. Okay, so before that, let me see
You expand that font for the video, Avilash.
again.
Yeah, for the video you need to expand, right? You need to be visible on the video. It's slightly there, it's just slightly more visible.
Yeah.
Yeah.
Yeah, now it's
Yeah.
better.
Okay.
Accessibility is an important issue.
Yeah. So I have around 5 lakhs plus students information in my database. So what I'm trying to do is like I'm trying to generate a XML sheet which pull all these 5 lakhs data and create it. To do that, I use Django as an app. Some code. Okay, good. Okay. I think this was first. Fine. So I just created a one small application which basically create a XML file containing all students' information. Right. So I'm going to click the first one. I start running. Okay. So we'll see how I created this first request. You can see this gen XML. You take a request, it just sitemap.generator, yes.write, and just give the data back. So it takes pretty long time, right? So to avoid this one, I just created another same method. I said generate XML using Celery. I said generate XML task.delay. Then I just give the task back, task ID back. Okay. So I'm going to click on the second link. It says that request has been queued and you will get the data shortly. So what happens here is actually the task, whatever we given dot delay, it went to the queue. Now you need someone to pick and start, right, process it. So the person who processed the task actually called the worker. Okay. So we'll see how to create a worker. So now I push the task. Now I just create the worker. Worker actually started processing the data. Okay, this can be run at any machine, any point of time. So same example I'm showing it here. We create a CSV file instead of XML process. So this is a one example, right? So in your basically the development life cycle, you are going to have different kind of use cases. The main thing is like creating an assets when you user do some kind of an action. When I talk about assets, for example, you have a let's say profile. So someone is upload his profile image. You need to create a thumbnail. When the user send the click on save and you start creating a thumbnail, it's going to take a lot of time, right? You want to create a 3 or 4 size thumbnail size, and the image size is a pretty big. Now everyone phone has a pretty good images, right? So it's going to take a bit long time. So to avoid that thing, the thumbnail creation can be pushed to the Celery task. Another thing is there are many people nowadays create a blog, forum kind of an application. So people basically what happens is like some particular thread has followed 101 people, and any event happen or if someone is commented on that thread to notify all the users. So when they say click on save, if you start sending the email, it's not going to end, right? So another thing is keeping search index up to date. So what happens if people are using Elasticsearch or Solar, you'll understand what happens is like when a database is get updated, you need to update the same data to search index. It's a bit tricky task because it takes so much of processing power and it's a bit slow. So what we do is like any event happens, basically we push the task to the Celery, and Celery will process it and update the search index. And the replacement of cron jobs. So if your application has kind of a multiple cron jobs set running periodically, I won't say that you have to immediately go and replace it, because if that will take a lot of time. Okay, so if you are using Celery for some purpose, this kind of image processing or kind of purpose, and that application has a cron tab, then you can replace it. And schedule activity from the UI. This is one of the important part. So many of the users you might be seeing if you have check the different website. You can say that okay, I don't want the notification happens from 9 to 6 o'clock because it's my office hours. Okay, after 6 let it happen. So we schedule the notifications or emails or whatever the task activity happens in the Celery, you configure through the UI. So what we can do is like we can tell the Celery to run my task only on this particular time, not on the other time. Okay, and much more things. Okay, so to set up these things and run it in local machine or anywhere, you need basically 3 main components. One is a message broker. Message broker can be a RabbitMQ or Redis or PyMQP, something is there. So things like that. So I will explain that later. Then you need to have a result backend. It is an optional. So result backend is like, okay, the task you ran completed, so you don't know the result of the task or whether it's failed. What is the state of the task? Nothing. It just went background. You don't have any idea about it, right? So to avoid that thing, we can have a backend so that it will track. It will show in the screen, or it can be a database or whatever it is. And last part is concurrency. So you wanted to run the task. We are keep pushing the task 10 to 15 tasks in a minute or seconds. So you need to have a concurrency, or you need to have a parallel execution mechanism, right? So that we can finish your task a bit fast. Okay, back to message broker. So I said like in the initial first slide, broker URL, and you put some URL there, right? So this is closely related to this message broker. So the broker URL is responsible to store a data in a queue. Message broker is a queue system which basically whatever the thing you do, basically function dot delay, it basically go to the queue. That queue is actually called a message broker. Okay. And it give the consumer to execute it. When you start a worker, the worker is online. What happens is like the queue server will basically, worker can pick from the queue server and process it. This is a small diagram how the Celery work. You have a producer. Producer can be a request, API request, or it can be a task trigger another task, or it can be just a Python script trigger a task, or it can be a shell script trigger a task, or a PHP program, anything. Okay, that is a producer. Producer basically produce a task and push to the queue. In this example, we have 6 tasks in the queue. The first one will be served the first. So the second part is actually the consumer. Okay, once it is there in the queue, consumer can pick the task. By default, Celery consumer will pick 4 tasks at a time. It's the default configuration. When the consumer pick the task state become pending. Okay, so it's not executed, it's actually went out from the queue. It's not there anywhere. Okay, only there in the consumer hand. Okay, after that, the consumer will give the task to the worker pool. The worker pool, when I talk about worker pool, like people are dealing with multiprocessing, multi-threading and all, or concurrency. Okay, you will be having a list of workers. So the worker will be start the task. That particular time, task status got started. Then here you get a 2 output. Either it can success or it can fail. Alright? The task is success, then you will get a success status, or if it's failed, you will get a failed state. So once the task success or failure, both of the case, the backend, if you have a backend, the backend will be storing the data. In failure case, what happens is like we are always know, okay, why it's failed, what is the trace back, right? Maybe an exception happens, so we wanted to know what kind of an exception happens. So that exception will be stored in the result backend. If it is a success, the function returns something, that return value will be stored. For example, if you create a task, add 2 numbers, pass 2 numbers, and the function return a plus b, okay, then 2 plus 3 is going to get 5 in the result. Another thing in the result, this states whatever I said will be saved in the result backend. So you push the task. Imagine it take half an hour to complete the task. So you wanted to know, okay, whether the task is in pending state or whether the task is actually started or success or failure. All right. So that can be also get it from the result backend. So we'll see a small demo, if possible. I think my system was down. So the thing what I'm talking about, this task result. So here what I did is actually the result backend I save in my Postgres database. So anything happens in the Celery, basically come here. There are two tasks. One says success on July 13th, yesterday, and today one task says failure. We'll see these two examples. What happens when task says success and what happens task says failure. Go for the positive side. So any task when you push to the Celery, you are going message broker. If I say, you are going to get a particular unique ID, which is called a task ID. And nowadays the Celery use JSON. Before it was a pickle. And the result say it is completed. Some task and the result say, okay, I'm done with my task. And if there is a traceback, you are going to get it in this box. And if some kind of a, this is another thing. So what happens like a task trigger another task, you need to know the chain, right? So that chain will be inside this meta information saved here. So you will be understanding, okay, this task is actually triggered another task, we can follow up using that. Back to the failure one. I don't know why it's failed. Yeah. So it's failed, and the reason is actually a demo exception or spelling mistake. I was just raising just a value error. It says that actually it's a demo exception. So you get the complete trace back. So we can use it to figure it out what's the problem happened when it's running time, on the runtime. So this is another example. What happens when people normally call an API. So there's someone's USN number. I don't know. So do anyone has a USN number? Can you just tell me your for SF 16 CS 060. Is it you? Yeah. Okay. So you are passed and you are from Sayadri. Good, you passed. You got good mark, I guess. Right. Okay. So what happens is the data which is actually in the system is already saved. I have 5 lakhs students information, I said. So all these informations are saved in the database. So it's just pulled basically. So simple API is actually created for demo purpose. So I'm just going to change some number. I don't know. I'm just going to say 600. I'm sure that this number is not there. So yeah, any student which send a USN number, I assume that okay, that is actual person is going to send it, that USN number is exists. So the data is not there in my database. I need to pull the data from PTO results or wherever it is, right? So I just basically pull, but I can't wait for the user to say that okay, I'm pulling, please wait. No, it will take a long time, right? So what I do is like, okay, it says that I just send the user, a USN is not found, then I just kick off the extraction task and I go to the USN VTU website and can scrape the data and put in the database. And the reference ID is this one. So I think something is here. Result.status or some API is there. If you call the task ID, it will show you whether it is success or failure or what is the status of that particular thing. So this basically explains you how the producer is the API what you requested, and the consumer consumes the data and give to the worker will save the data in the database or process it, and the result will be seen in the result bank. Okay, so I was just talking about message queue, message broker. So when Celery was built, Celery was kept in mind that okay, I have RabbitMQ in my hand, so I can build the entire system. So that was their concept. So all the thing what you need to process any kind of task, and the failure, success, or what happens, the worker is lost, all things are actually handled by the RabbitMQ. Sorry. RabbitMQ implements AMQP protocol, async message queue protocol, and what I said, like it tracks all the tasks, whatever went and whatever the success, whatever is got failed, and everything will be acknowledged by the RabbitMQ. Okay, so till we always talk about the positive side of the implementation, we'll see what happens the things start failing. I said Celery completely depend on a message queue. All the tasks whatever you push basically go to the message queue, and the worker pick from there. What happens, the message queue itself goes down. You have only one message queue and it's complete. I said like worker can be multiple. You can put a multiple worker. If the one worker goes down, you can pick the other worker, right? So, and everything is actually in the message queue, and that itself is went down. All the tasks start failing, right? You can't push anywhere. So, RabbitMQ has a mechanism to replicate this solve this problem by using the replica. So we follow something called a leader followers methodology. So what happens is like you are creating a two or more RabbitMQ servers put in a particular node or particular network, and RabbitMQ will basically copy all the queue data to all the machines, all the system, and once it goes down, other system will be having the queue, and you can get it. Disadvantage of this, basically you are simply unnecessarily creating so many system, and all the data what we have in the server 1, the same data will be there in the server 2, the same thing will be there in the server. Okay, and that is the one biggest problem. Unfortunately, we can't do the load balancing. So we have a 3 message queue servers. So let me do the load balance, is not possible. So it doesn't know where to acknowledge. Okay. So as I said, like in the beginning, result backend. Little more detailed about result backend. So it basically track all activity, all things happens in the worker side. Worker can be in any of the system, and this track happens just using that task ID, a task ID and the result. So you can see here, a task, it's just map happens just a task ID and the result. So result will be basically it's a JSON object. So you basically store it in once you have a JSON object, it's easy to store it in any of the things, right? Either it's file or database or wherever it is. You can use Redis as a backend server. So Redis advantage is like it is a key value pair, and it's pretty fast. So distributed parallel processing. So now we talk about a single worker is running in a one machine. You push the task, that worker will be. So imagine that you have tons of task pushes every day into the system, into the queue, and one worker is not enough to handle all these things. You have 2 options. You can create another server. I can run a worker on that server. Okay, so you can execute it from there. Second thing, you can use a same server itself. You can start a worker on the same server. So the second disadvantage of the second one is actually you are going to use the RAM. Every time you use the spawn the new worker, it's create a big footprint of RAM. So you should be careful about when you do it in a single system, single machine. The last one is basically you can use the concurrency mechanism. Okay, say single process, do the concurrent way of doing it. So to do that, the above two cases we run the default command celery minus a app name and worker. The last one, the concurrency, we have something called minus C. If you don't pass the concurrency, by default it takes CPU count is a concurrent number. So if you have a 4-core processor, your concurrency will be 4. It's 2, it will be 2. So how the tasks are consumed by the worker, right? You said I push the task to the queue. Now what happens from the queue, right? So basically worker will be listening the queue. When any task comes, if the worker is free, you start picking the queue, picking from that. But the problem is like it runs in a completely different machine and you are not going to see in the terminal whether it is running or not, right? So you don't have any idea when this task is going to run. If you have a queue is pretty huge and the task takes 5 minutes to run one task, and if you have a 10 tasks send at the same time, you take a last task is going to take start execution maybe a long time, right? So you need to plan for that. So if you are using some database, reading from the database and processing it, and by the time the database value might be changed, or maybe user was waiting for your response back, and you take almost half an hour to process it, it may be effect. Another thing is like when your tasks are consumed, you should be careful about database transaction because the concurrency or multiprocessing. So in the database, what we can do is we can read the data parallel at the same time, same row we can read, but when you write it, you have a problem, right? So you might be knowing about what is database transaction. So this issue has to be handled when you do parallel processing. And very important part, the people who use Django or kind of ORM things, they are literally lazy people. They take the object, directly pass to the task. So that the object has foreign key and all the things, you don't want to pass 10 to 15 parameter to the function and keep track of all the parameter, right? So we just pass the object and you process that object. Should never do that. The reason, when you pass the object, that particular time the value of the object may be in some kind of value. Some other task came, pick the database for that particular object and modified it. This object what you have still with the older data. Okay. So always when you do this kind of things, take the object, take the ID, pass to the task. In the task, query it and get it. And so what happens when we send a task? It's went fine. Message queue is there. Okay, it consumed it. So when I was just trying to log into, or when we are started generating XML file, my disk was full. I throw an error. Okay. In this scenario, you have something called a retry, or any unexpected exceptions happen. We can say okay, retry. So this is an example I just directly taken from Celery documentation. What these people explain is like, they need to log into the Twitter account and then to just send some messages. Okay. So when they try to log in, it can fail. First attempt is failed, so they can send it again. Okay. So here what you are saying is self.retry, and you have to see in the beginning the task. It's a decorator app.task, and you say bind is true. So when you say bind is true, it take an argument called self. So you can say self.retry. So the function, the same task will be retried. Okay. So this retry will take multiple arguments. One is an exception, why it's failed, that will be carried forward. Another thing is, okay, you are immediately not retrying. You will take, okay, little bit time. So it's failed now. Let me wait for 5 minutes, then try it again. It's called countdown or delay, ETA. We can give ETA, expected time. So, or we can say countdown. Countdown 2 minutes. So after 2 minutes, it's execute. So I'll give another demo. So this is done. Before going to the demo, I said like tasks are pushed in the queue and it is running its own, right? What happens if exception happen when you sleep or you are doing your job and that particular exception happen? Are you going to check the terminal every time? No. So you have to have some kind of a mechanism to notify you, okay, this task was running, some reason it got failed, and you want to know what the reason, right? So there is some good tool available, it's called Sentry. Okay, so we can push the any exceptions to the Sentry. Sentry will basically show the exception and the traceback. I will see how we can do that. This is the task. I just raise an exception. Start the workflow. So this is the first demo, so I just given an exception in the screen. So I just clicked it. It said it's everything is done, right? So if you are actually in the screen, basically you can see there is an exception, right? Most of the time you won't be open the screen and see it. So how to solve this kind of issues? Right. We'll see that thing in something called Sentry. This is free for developers. So I just created an application. Okay, this application I configured it. I will explain you how to configure this thing. So you can see the exception what happened in this particular time. So the time is this. I think this is the right time. And it gives some kind of an information in the beginning. It says that okay, this is kind of a release version. All the application which are the product we build it, we have a proper release version. And which server is actually came from, because I said it is a distributed, so it can send it from any of the servers. And which is the site, or if you are building a UI or something, you can see that the site domain name. And this is transaction means like this is that file. And few other information, whenever you get time you can go through these things. So it say that okay, this is a function, but this was the exception happened. Okay, that is not enough for us because we don't know which was the task, right? So we'll see the task information. It says that okay, this was the task ID. So we know the task ID, and we know why this exception happened, because it gives basically all the traceback and all the information for you. So, and good part of about this one is actually it immediately send a email to your mobile or wherever it is. So you'll be notified the task is failed. Okay. So you are tension free. Push the task. Relax. So we'll see how to configure this thing. It's um, okay. You have one library is required for doing this thing, that's called Raven. Has to be installed. Okay. I said in the beginning, when we create Celery application, what we do is we import from the Celery and we create an instance of Celery. That is an application, right? Uh, Correct. We imported from the Celery and created a C app. We are running that this thing. So here is bit different. What I did is I created a class, Celery class. I inherited from the base Celery. Then the base Celery has some function called on configure. What happens like an instance code get created, you do some kind of a configuration. Okay. When you do the configuration, we can pass a small piece of code. This much. Just do all this work. Okay. So this is the library I said. It just create a client. So we have something called a Sentry DSN. It's a URL of the Sentry with a token. When you are registered to the Sentry, you will get this token. Then if you have kind of a release or something, you can just put this is a release version. That's it. Rest everything will be taken from the log. You are seeing that which is the server and what is the log status, and all the things information will be taken on the fly by the Raven library. And at the end we just register the signal to the basically to use logger library. So we just register it. Plan is equal to this one. Logging is actually warning. So when we say log level, above the log level warning or above that, it will be sent to the center. So if you say just info plus, now it's a debug. And at the end we register the client. So then we create the app using the Celery class itself, Celery class which I created. So that's it. So any doubts?
Any questions?
Any questions?
Good.
About the message broker,
Mhm.
I mean, is it configured only for RabbitMQ, or can we use MSMQ or kind of thing?
Okay, the question is message broker. It's only for RabbitMQ, or we can use any other message brokers, right?
We can,
Yeah. So basically, we can use any kind of. So you can see their documentation. Basically, they say RabbitMQ, Redis, and Amazon has something. So we can use it.
Because with the Windows also we we have MSMQ. So
Okay.
Any other question for Abhilash? No? Going once? Going twice? Sold, thanks.
Thank you.